What we're going to do now is look at three kinds of insulation that are used for low and medium temperature applications: fiberglass, cellular rubber, and plastic foam. Now, from our discussion of the functions of thermal insulation, you may remember that insulation can be used to keep systems hot or to keep systems cold. Cellular rubber and plastic foam are used to keep systems cold. Fiberglass can be used either way, as low temperature insulation or high temperature insulation, up to about 400 degrees Fahrenheit, 200 Celsius. Because of its two-way temperature range, fiberglass may also be used for some special applications. One of them is heat-traced piping systems. Heat tracing is a way to prevent the contents of a piping system from thickening or freezing in cold weather. A small steam line or an electric element heats the pipe along its length. The insulation keeps the heat from escaping. If it's an oil line, the oil will flow freely. If it's a water line, it won't freeze up, even if outside temperatures are very low. The first maintenance procedure we're going to see is the replacement of fiberglass insulation on a heat-traced water line. You'll notice that the insulator wears a filter mask, goggles, gloves, and long sleeves. That's because fiberglass irritates your skin, eyes, and lungs wherever it touches you. He's taken one additional precaution. He's made sure that the electrical heat tracing has been turned off and tagged out. As you can see, this insulation is badly in need of replacement. It's easily removed by cutting the tape with a sharp knife. But be careful. The flat plastic element is the electrical heat tracing. When you're working on runs that are heat traced, be careful not to damage the tracing with your tools. It could be a shocking experience. Now, even though it's tagged out, when it's turned on again, a damaged heating element can cause real problems. The new fiberglass insulation comes in preformed pipe sections with seams along the length where the insulation opens up. One side of the seam laps over to hold the insulation on the pipe. The lap seam is stapled all the way up. The staples should be spaced about 6 inches apart, approximately 15 centimeters. The end joints are sealed with tape to prevent heat losses through the cracks between sections. The ends of the tape are stapled to make extra sure it'll stay on. The seams are covered with cement to help seal out moisture that would tend to condense on the pipe in warmer weather. A good thick coating seals in the seam and plugs up the holes made by the staples. Working with fiberglass isn't difficult. It's light, easy to handle, and any special trimming can be done with a sharp knife. The example we've just seen demonstrated was the installation of pre-made fiberglass insulation for piping systems. But you're also likely to see this kind of insulation used in several different forms. It comes in blankets, stiff boards, and loose bats for different purposes. Whatever form it comes in, the same safety precautions apply: eye protection, a filter mask, gloves, and long sleeves. The important thing is to keep the fibers off your skin and out of your eyes and lungs. Fiberglass is one of the more versatile kinds of insulation. It's used both for low temperatures and high temperatures, up to 400 degrees Fahrenheit, 200 Celsius. Let's move on now and take a look at some kinds of insulation that are used especially for low temperatures: cellular rubber and plastic foam. Cellular rubber and plastic foam insulation come in tubular sections for insulating chilled water or refrigerant lines. They also come in blocks and sheets for special applications. The material is filled with thousands of tiny bubbles that act as dead airspace between the pipe and the outside air. Cellular rubber is made with closed cells. The bubbles don't interconnect. Plastic foam can be made either with closed cells or with open cells, where each cell is connected with others in the material. Both kinds of low-temperature insulation look pretty much the same and perform the same functions. They keep the pipe cold and keep moisture away from the pipe. The outside of the insulation acts as a barrier to keep water vapor from entering. If the vapor barrier is punctured, water vapor can enter the insulation and condense on the cold piping. Condensed water dripping from cold pipelines can damage sensitive equipment below, or create a safety hazard by forming a puddle on the floor. Cellular rubber and plastic foam both provide their own vapor barrier, but they have to seal properly. Let's watch as a workman repairs the cellular rubber insulation on a chilled water line and see how it's done. First, the damaged section is cut away from the rest of the insulation with a sharp knife. Cutting the ends squarely will make it easier to fit the new piece when the insulation is replaced. Once the ends are cut, the piece is removed from the pipe. Next, a length of new insulation is laid out along the gap. The new section will have to be cut to exactly the same length. He marks the distance with a shallow knife cut. Then he lays the section down and cuts the new piece to the correct size. This type of insulation comes in tubular sleeves. To fit it over a pipe that's already installed, it has to be slit along its length. On new installations, the rubber sleeves are usually just slipped over the ends of the pipes before the pipes are put up. To seal all the joints tightly, a special adhesive is used on all surfaces with rubber-to-rubber contact. First, adhesive is spread on either side of the gap. Then, the ends of the new piece are prepared. The adhesive sets up on contact, holding the insulation together and providing an airtight seal against water vapor in the air. Both sides of the long seam are brushed with the adhesive so they'll stick together as soon as they touch. When all the seams are coated with adhesive, the insulation is mounted on the pipe. Squeezing the seams sticks the insulation together, so the worker has to get it right the first time, or the job may have to be done over. He starts at one end and works toward the middle. Then starts again at the other end and works back. That way, he knows the ends will match up when he's done. The usefulness of the insulation largely depends on the quality of the vapor barrier. All the seams must be carefully sealed to keep water vapor out. Working with cellular rubber insulation is pretty easy if you remember that the important thing is to make seams and joints airtight. Plastic foam works the same way. It's installed like cellular rubber. One difference is that it's likely to be more rigid. Otherwise, they're very similar. In this segment, we've discussed two kinds of low-temperature insulation, plastic foam and cellular rubber. And we've seen one kind that can be used both for low and high temperature applications, fiberglass. When we return, we'll be looking at a kind of insulation that can be used at any temperature, from the lowest to the highest.